Hi, my name is Dr. Anna Scott, and I'm the Chief Science Officer and co-founder at Project Canary. For those who aren't familiar, Project Canary is a Colorado-based B Corporation, and our data and analytics audit the energy supply chain and enable companies to work towards net zero. We do this with a certification technology that identifies best-in-class well pads from best-in-class producers. On top of that, we layer what I'm here today to talk about, which is our real-time monitoring, which combines stationary sensors with the cloud dashboard and analytics to drive forward operational improvements. At Project Canary, our approach to methane emissions monitoring is to focus both on the frequency of detection as well as the accuracy. This is really critically important because many emission sources are intermittent, and catching the majority of leak sources requires having a sensitive detection limit. We built this sensor because we saw that there was a space in the market and we thought that we could fill it. But I want to be really clear, at Project Canary, we do have hardware, but we're hardware agnostic, and we're actually open to use our platform to work with any and all types of sensors that meet high fidelity standards. But to talk through our Canary sensors, here I'm showing an image of one of our Canary sensors. They come in kind of two flavors. One is our VOC or total VOC sensor called our Canary S unit, and then our methane specific unit, which I'll talk more about today, which is our Canary X unit. The whole package is modular and affordable, has a cellular connection. In addition to this, in addition to the chemical sensing, we pair it with an anemometer. So that's this bit up here that provides precise speed and wind direction. This is really critical for mass quantification as well as source attribution and analytics. We can also pair the sensor with a SUMA canister that can be automated. So that means we can take a grab sample based off of thresholds that you set out in the field. And of course, all of this package is solar powered and IoT enabled. That data flows up to our cloud databases and is available in real time. Here, I'm showing data from one of our customer sites. This combines chemical data, wind speed and direction, and then alerts that get set automatically. This data can also drive insights into field level operations. Here I'm showing is a time series of data for VOC sensors that allows operators to quickly pick out which pads are having problems. And more recently, we've begun rolling out our mass quantifications data, which combines a time series of mass flux along with source identification. This is what our sensors look like out in the field. On the left, I'm showing a Canary S unit out in the DJ Basin, along with our team of certification engineers. And on the right, I'm showing a Canary X unit at the Colorado State University METEC facility back in February of this year. The Canary X sensor measures off of a tunable laser diode absorption spectroscopy or TILDAS-based approach. Specifically, it's measuring for methane with a concentration range ranging from 0 to 10,000 parts per million. It has a lower detection limit of 400 parts per billion and a precision of about 250 ppb. The sensor natively samples at about 2 hertz. It is actively aspirated, but we average up every second, and then we report to the cloud every minute. As you saw from the previous slides, the temperature operating range is quite large, from down to -10 Celsius, or that picture is actually even colder, up to 65 Celsius, which covers a very wide range of operating conditions. This technology itself has been extensively validated, here showing results from laboratory testing, showing an R² of 0.99 on the right, as well as field work at METEC, here showing a detection caught within 12 minutes, as well as blind results that show a hit rate of 100%. When you place this type of sensor technology on site, it's capable of capturing most field emissions, depending, of course, where you place it on site. And when we plug this into the Fugitive Emissions Abatement Simulation Toolkit, or FEAST, it shows that using Canary in conjunction with follow-up LDAR can help avoid over 80% of emissions in the oil field. And so this is all great in theory, but how has this worked in practice? Well, I'm excited to share some of these operator examples of how people have used Canary to fix leaks faster, from a frozen liquid knockout tank that was identified and remediated within 73 hours, to an open thief hatch that was found and closed within 4 hours. Honestly, sometimes we find and fix these sooner. To my personal favorite, a water hauler that was not using their vapor recovery lines, who was caught within 10 minutes, and who was actually fired that very same day. So if you're interested in emissions reductions, please don't hesitate to reach out to me anytime, anna.scott@project.canary.com, or feel free to schedule a consultation on our website, projectcanary.com. Thanks.